Hello everyone, so today we'll start with assembly day 9, that is advanced mates. For that we are going to browse parts here. From the folder I'll select the required part, that is frame. So now we are going to do one window assembly in which we are going to see at least 3 mates, that is width mate, limit angle mate and symmetric mate. So to start with mates, I'll call the second part. But before that, we need to complete our process, that is combining assembly origin with the first part origin. So I'll make this part right click and say float. After floating the part, you can see the part is moving now. We'll call the mates here and select the required mate, that is coincide. For that, I'll select the first assembly's origin and then the first part's origin. Now both the origins are coincided with each other. I'll say it okay. We have seen already there the advantage of coinciding the center points or origins is that the planes of assembly and first part will be matched here. You can see the assembly planes and first part planes are been together here. So the assembly will work from the center plane reference only now. Next we are going to call the other component, say browse. And now we are going to take the door here. After calling the door, first we'll go for concentric mate. So I'll select the required selections here, that is hole and shaft. And now both the hole and shaft are being concentric here, but the window is still moving in linear direction. Now we can see the length of the window. The height of the window here is given as 546 mm and the inner height of the frame is given as 550 mm. The difference is of 4 mm. So if I want to place this window at center, I have to keep clearance of 2 mm from upper side and 2 mm from lower side. So for that we are having three options here. First option is to lock the midplane of door with the midplane of the frame. So I'll go for that mate. I'll select the top plane of assembly and similar plane, that is top plane of door. Now you can see the door is aligned in the center as the mid center planes are matched here by coincide mate. So this was the first option given. I'll delete this option and go for another option. I'll delete this mate. Again the another option is by applying distance mate. So for distance mate, select the mate. Go for distance and say 2 mm distance. First phase and second phase. Now the clearance here is 2 mm from upper side. Same is going to be for lower side, that is 2 mm only. So again the door is placed at a center. So this was another option, the second option, that is distance mate. But we are here to see advanced mates. So I'll delete this mate also. And now in advanced mate, the first option we are going to see here is width mate. The work of width mate is to align the part at the center of the given references. So it will make this door at equal distances from upper and lower side. So I'll go for width mate here. Select the required references. First we'll select the references of frames, that is upper and lower face. And then we'll select these references of door, that is the lower and upper face. You can select the first selection as door also and then frame also. You can go for the reverse selections also. First you can select the door faces and then the frame faces. Now you can see the constraint mate is width mate and the door will automatically come at the center of these two upper and lower faces of the frame. Say it okay. Means you have to go for 4 selections, that is upper and lower face of the door and upper and lower face of the frame, inner sides. Now width mate has been applied here. Again we are going to repeat the same mate, that is coincide and width mate for the next door also. So we'll start with mates. Go for the selections again, that is concentricity between this shaft and hole, and then applying width mate here. In advanced mates go for the selection of width mate. In width selection, we'll select the doors faces first, upper and lower side, and then the frames faces. And this door is settled at the center now. Say it okay. So again the width mate is applied here. Now you can see both the doors are rotating at 360 degrees here. So I need to restrict this door at particular angles by giving it maximum and minimum angles now. So in advanced mates, we are going to apply limit angle mate here by applying two limits, that is maximum limit of angle and minimum limit of angle, so that the part will reciprocate in between that two angles only. Similar kind of mate we have seen in standard mates angle mate also. We don't need to provide limit angles, that is maximum and minimum. only one angle was needed so as to constrain the part. But in advanced mates, we need two angles, that is maximum angle and minimum angle. So we'll go for mates and select the advanced mates. If you select the standard mates, you can see the angle here. Only one angle was needed. But now this time we are going for advanced mates. So here if you select the angle mate, there are three values given here. That is, first one is initial value that lies beside the icon of the angle mate. Second is the maximum value and third is the minimum value. So here we require only maximum and minimum values that are important. This initial angle value doesn't matter if you keep it 0 degrees, 45 degrees or 90 degrees, any angle you can keep. It is just the start initial position of the part. But maximum and minimum values, these two values are important here. So for the selection of angle mate, I need to select this front face of the door and front face of the frame. So maximum angle I'll keep it here as 120. I'll say 108 degrees. And minimum angle I'll say it's 0 degrees. Selection of two faces I have given here, that is frames front plane and doors front plane. Say it okay. Now you can see here, now this door will not exceed behind the frame, neither it will exceed the angle of 108 degrees in front side. It is because limit angle made is been applied here. So it will take 0 position here and maximum 108 degrees position here. So this is limit angle made. This is minimum limit, that was 0. That's why these two faces as we have selected for angle made are coplanar with each other, and the minimum and maximum angle are given as 108 and 0. So this was limit angle made. We're not going to apply this limit angle made on this frame or this door. It is because we are going to apply a symmetric mate, and due to application of symmetric mate, so we don't need to apply limit angle mate on the second door here. We'll go for mates. So now we are going to see a symmetric mate. So for symmetric mate, you may require a center plane. So we are having a center plane here as right plane, and we need to select two faces of the opposite parts which are going to be symmetric with the center plane. So in advanced mates, select the symmetric mate. It is asking for symmetric plane. As we have discussed, we are going to take right plane here. It is coming in between the assembly, that's why I'm taking right plane. So in symmetricity, you need to consider that whatever two parts which are going to be symmetric, the plane should be lie in between that two parts. That's why I'm selecting the right plane here as a symmetric plane, and we have to give the selection of two faces of the parts which are going to be symmetric. So I'll select the two faces of the parts here. I'll select the inner face of this first door and the inner face of the second door also. The selection should be similar. If you are selecting inner faces, then select the inner faces of both the doors. If you are selecting outer faces, then select the outer faces of both the doors. It doesn't work if you go for inner face selection of first door and outer face selection of second door. So here the symmetric mate has been applied, say it okay. And now if you drag this door, the first door will follow the limit angle mate that we have given here. You can see in mate history at left side bottom side, the limit angle mate was given to the first door only. So it will follow the limit angle mate. But the second door we have not given any limit angle mate. It is following the first door just because the symmetric mate was been applied. So the first door's movement will be copied for the second door also due to symmetricity mate. Again, I'll repeat the selections here. So for symmetric mate, you need to select one center plane between the two parts to be made symmetric and the two faces of the parts that are to be made symmetric. Say it okay. This way symmetric mate is also been applied here. So this was limit angle and symmetric mate. Now the next mate we are going to see here is linear coupler mate. For that I'll call the parts here. This is the first part here, that is track rail. In the second part I'll browse here as this rectangular rail. Mate selection, I'll go for mates here again. First will coincide the origins of first part with the assembly origin. For that go for mate selection and then select the assembly's origin first, and the first part was this track. So I'll select the origin of the first part also again. But as I say okay, the mate is not been applied here. It is showing error. This is because I have not made this part float in condition. So it is compulsory for us before applying mate that the part should be float here. Then only we are going to apply coincide mate. So I'll right click and say this part as float and then go for mates. Select the assembly's origin and the first part origin, that is track part. Say it okay, and now the planes are matched here. Now I'll go for second part. I'll place this block on this track here. For that I need coincide mate first. I'll select the coincide mate, select the bottom face and the second bottom face. Say it okay, again okay. Now this part is moving, so I need to apply width mate there. I'll select for mate option and then go for width mate. In advanced mate, select width. First selection, I'll select the side of the block and the other side of the block. And then in tab selections, I'll select the two faces of the track, two internal faces, so as to make this part at the center, so as to place this part at the center of the cutout. Say it okay. Now you can see the distance of the block was 50 mm and the track in between distance was 54. So by applying the width mate, 2 mm clearance has been also applied here. That's why we used width mate here, so that the part is placed at the center of the cutout. Next option, I'm going to apply a limit distance mate. That is the new mate we are going to see here. So for limit distance mate also, you have to apply two limits, that is maximum and minimum. We will go for limit distance mate here. Select the limit distance mate tab here. You can see maximum and minimum distance. So in advanced mates distance mate, we have to apply two distances, that will be maximum and minimum. Initial distance is here. It is given beside the symbol of distance mate. So I'll take the initial distance as 0. The values that matter here are maximum and minimum value. So the maximum value I'm going to take here is 110 mm and the minimum value here is 0 mm. So for reference selection, I'll select the back face of the track and back face of the block. We are going to apply limit distance made between these two faces. I have selected both the faces, applied the maximum and minimum distance and then say OK. Here you can see the part is moving at 110 mm, but it is moving in a reverse direction. So to solve this issue, I'll again go in mate, edit the limit distance made feature and then flip the dimension here. You can see this option, flip the dimension. It will reverse the distance dimension here. So now it is going to move in right side direction, maximum 110 and minimum 0. So this was limit distance made. Sometimes there is confusion, as we are having standard mates, there is also a distance mate, but this distance mate is different from limit distance mate of advanced mates. Here you need to apply only one distance, and in advanced mates you are going to apply maximum and minimum two distances here. So that's why limit distance mate is different from standard mates distance mate. Say it okay. We have applied maximum and minimum distance to this part. Now I need one copy of this part, so I'll press Ctrl, hold the Ctrl key and then drag the part so as to make the copy. Go for mate option again. Select the bottom face of the bar and the face of the track. Say OK. Advanced mates. Again repeat the width mate here to align the part in center. So now width mate is also been applied, but we are not going to apply limit distance mate to the second block here. We are going to see one new option, that is positioning the part without applying the mate. For that I'll go for mates option. Now we require this part to be placed in such a way that these two in between distances of the faces, first face and second face, the distance should be 10 mm. If I randomly place this part here, it is not going to take 10 mm distance. For that one option is given there in mates. Go for that option, select the mate option. We'll select the required faces and then go for the distance mate. Apply the required distance. I'll say it 8 mm here. But directly before saying it OK, we are going to tick on this option, that is used for positioning only. What this option will do is, it will not apply distance mate directly. It will just position this part at 10 mm distance from the first face. Say it OK. Now you can see in mate history, distance mate is not been applied here, but the part is been positioned at 10 mm. We can check the distances. Just control press and hold the control press key, then select the both faces. You can see the normal distance showing here as 8 mm without applying the distance mate. Now we'll go for linear coupler mate. Select the mates option. In advanced mates, go for linear coupler mate. We have to give similar side selection of the faces here. That means if I am going to select left side of this first block, I select the similar face of the second block also. That is left face. So if you are selecting left face of first block, you have to select left face of second block also. You have to watch the ratio also. It is showing here as 1:1. So the speed coordination between these two parts will be 1:1. That means if this part moves at 10 mm, this will also move at 10 mm only. Say it okay. Only two selections were required. That was this face and the other part similar face. Left face and the other left face. If you are selecting right face for the selection, then for second part also you need to select the right face only. Now here we have applied linear coupler mate. The mechanism of linear coupler mate is such that if I move this first part, the second part will also move because of coupling, that is linear coupler mate. And now suppose if I edit this mate, and here I'll change the ratio by 1:2. So the speed will also be varied by 1:2 ratio. It means if this first block will move 10 mm, the other block will move 20 mm here. You can see here the speed ratio is changed. The second block is moving 2 times faster than the first block here. It is because of change in ratio. So that is the importance of linear coupler mate, that you can couple and move the part in required ratios. That is 1:1, it may be 1:2, it may be 1:3, and then say it okay. So now the speed ratio between first and second part is 1:2 and linear coupler mate has been applied here. The next mate we are going to see here is path mate. The concept is very simple. There will be two parts. First part is having path and second part will have the vertex point, and the part will move according to the path being drawn. So for that I am going to browse the parts first. In desktop I'll go for day 9. Here we are having one plate. We'll call this plate here. As it is the first part of assembly, say right click, float, then mate, assemblies origin with the first part origin so as to match the center planes. Then we are going to call the second part, that will be the slot strip here. Now we are going to make one mate, that is concentricity. We need to select only the circular faces so as to make this part concentric. Say it okay. Now I'll see the movement of this part. Again I'll apply one mate here, that is coincide mate between the bottom face of this part and upper face of the plate. Say it okay. You can see this part is concentric and coincide with the plate now. We are going to see one more mate here, that is slot mate, which lies under the category of mechanical mates. So for that I am going to call the next part sliding pin, say open, and now go for mates. In mates I'll go for mechanical category and apply the slot mate here. For slot selection, select the circular face of the pin and circular face of the slotted link here. You can see the slot mate has been applied. We'll also go for coincide mate here between the bottom face of the upper head of the pin and the upper face of the link. Say it okay. Now as we have applied slot mate, this part will only travel between the slots here. It will not leave the slot here. The selections for the slot mate were circular face of the link and the circular face of the pin. After applying slot mate, I'll place this pin here. Now you can see one path. So this pin will follow this path by applying path mate. Now this path was made on this face. So this path is coplanar to this face here. I just need to apply one vertex point in this pin so as to follow the path. But the question is where to apply the vertex point here. Suppose if I apply this vertex point on the upper head, this pin is not going to move downwards so as to catch this path. So we cannot apply the vertex point at the upper side. Neither we can apply this point at the lower body. So the requirement here is to count the distance between the upper face of the pin and this face, as this path was coplanar to this face. Before applying path mate, we need to place one vertex point here. The vertex point should be at level of this path. So this path was made on this face and the normal distance is coming here as 13 mm. So I'll open this part, say open part, and after opening only I'll place this vertex point here. Go for the selection of mid plane, say it sketch, and after saying sketch, place the point here, say smart dimension, and from the upper face we have counted distance was 13 mm. So I'll place this point at 13 mm distance only. It is because it should grab the point of the path there. We'll constrain this point here by applying the vertical relation. Then close the part by saving this change here. Close the part. Now you can see this vertex point has also been applied. Same at the level of this path, that is from upper face 13 mm distance. So the basic requirement is that this path and the vertex point should be coplanar, should be at the similar plane. That's why I have applied the 13 mm distance. Now I will go for path mate here. Select the mate option. In advanced mates, go for path selections. In component vertex selection, I will select the vertex point, and in path selection, I will select this line here. But as we have selected the line, it is not completely selected. So for that, we'll go for selection manager. We'll select this sketch here and set it as open loop and then OK. I've set this as open loop. This is because it is not a closed sketch. It is starting from this point and ending at the other point. That's why I've selected open loop here. Said OK. And now as the path made has been applied, the pin will follow the path made here. Same time, it will not exceed the limit of the slot made and it will remain in the link there. You can see here the movement of path made and slot made being together applied. We cannot apply slot made in this condition. It is because slot made require only one combined sketch, but this path was made by combining more than one sketches, that is this line, then arc, then the other line. So in this scenario, it is not possible to apply slot mate there. That's why we have applied path mate here. So this was the last mate of advanced mate, path mate. We'll stop the lecture here. Thank you.